Oxidation states let us keep track of electrons in oxidation reduction reactions by assigning charges to the various atoms in the compound and seeing if and how those charges change from the reactant side to the product side. Oxidation state and oxidation number are the same thing and they are used interchangeably, so don't be confused. If I switch back and forth, oxidation state, oxidation number are the same thing. So there are a few rules that you'll just have to learn for assigning oxidation state. The first rule is any atom in a pure element has an oxidation number of 0. So what that means is when you have a solid metal by itself, its oxidation number is 0. So sodium here has an oxidation number of 0. Chlorine is one of the diatomics, so chlorine oxidation number as Cl2 will be 0. So basically if it's an element by itself, without a charge, it's not an ion, it's a neutral element by itself, or it's a diatomic, its oxidation number is going to be 0. If you have a monatomic ion, its oxidation number is equal to its charge. So monatomic ion is a 1-atom ion, and its oxidation number is equal to its charge. So if I have the copper 2 ion in my reaction, the oxidation number of copper 2 is +2. If I have the fluoride ion in my reaction, its oxidation number is -1. It's just its charge. The oxidation number of a metal will always be equal to its charge. So in sodium chloride, the oxidation number of the sodium is +1 because sodium always has a charge of +1. In the copper sulfate, the oxidation state of copper is +2 because sulfate has a -2, so the copper has to have a +2 charge to balance it out. So when you have an ionic compound, a metal, nonmetal, you can always assign the oxidation number of the metal first because it is just the metal's charge. Oxidation number of hydrogen is +1. There is a rare instance where it's not, so we're just going to say oxidation number of hydrogen, no matter what compound you have, is +1. And then when you are dealing with nonmetal situations, you go by electronegativity. So the most electronegative elements are given their oxidation states equal to their charge. So the fluoride charge is -1, oxygen is -2, chlorine is -1, and nitrogen is -3, just from the periodic table, right? But you have to go and assign the most electronegative element its oxidation number first, and then figure out what's left over to figure out the other one. So in the NCl3, chlorine is more electronegative than nitrogen, so chlorine is -1. Each chlorine has an oxidation state of -1. There are 3 of them, so that's a total of -3. So nitrogen, in this case, is actually a +3 to balance it out. So again, nitrogen's not always going to be -3. It's only -3 if it's the most electronegative element in the compound. In OF2, fluorine is more electronegative than oxygen, so it gets its oxidation state assigned first, -1. And then you figure out oxygen based on kind of what's left over. So the fluorine is -1, there's 2 fluorine, so that's a total of -2. So oxygen has to be a +2 to balance that out. Lastly, the sum of the all oxidation states must equal the overall charge of the compound. I was kind of doing that on the last slide where we had neutral compounds. So in NO2, that's neutral. Oxygen's more electronegative than nitrogen, so the oxygen is -2. There's 2 of them, so that's -4, so the nitrogen has to be +4 to get a neutral compound. In the HPO3 2-, hydrogen is a +1, because hydrogen's always +1. And then I'm between phosphorus and oxygen. So oxygen is more electronegative, so we're going to do that one first. It gets its charge of -2. So basically what I have here at this point is I have a +1 for the hydrogen. I have a total of -6 for the oxygen. Each oxygen is -2, which is really the oxidation state of oxygen, but I need to know the total to calculate what phosphorus is. I need to get an overall charge of -2. So -6 + 1 is -5. So to get an overall charge of -2, phosphorus has to be a +3. Let's do a little bit of practice here. So again, when you have 2 nonmetals, the more electronegative element gets its charge as its oxidation state. So oxygen is -2. Carbon has to be +4 to balance it out because there are 2 oxygens, each with a -2 oxidation state. SF6, fluorine is more electronegative, so it gets -1. There are 6 of them, so that's -6, so sulfur has to be +6 to balance it out. When you're dealing with polyatomic ions, each element within the polyatomic ion has its own oxidation state. So you treat it just like any other nonmetal compound. So oxygen is more electronegative. It gets its charge of -2. There's 3 oxygens, so that's -6. I got to get to an overall charge of -1, which means in this case nitrogen has to be a +5 to balance it out.